Failed print, failed print, fail, 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 mega fail. Let's dive into the 3D printer that churned out all these flops and see what went wrong. Hey guys, CJ here with Elevated Systems. Today we're looking at this fascinating contraption, the FLSUN T1 3D printer. Now, I'll be straight with y'all. While I managed to get some high quality prints fairly quickly, more than half my attempts ended in failure. To make matters worse, each failure was caused by a different issue, ultimately leading to a completely dead machine. So let me walk you through my journey with the FLSUN T1 from an exciting machine full of potential to what is now a giant paperweight. Now, I'm going to approach this video like any other review. I'll take you through the unboxing and assembly of the T1, cover its specs and features, and walk you through the included software. We'll also look at some considerations for filament selection and settings. I'll showcase the successful prints I managed to produce, as well as the failures. For each failure, I'll explain the issue and try to diagnose the cause. Finally, I'll discuss why I decided to go ahead with this review video on a failed machine, even though FLSUN definitely didn't want me to. Now, unlike the larger S1, which I believe comes fully assembled, the T1 arrives as a kit and requires some assembly. After unboxing all the parts, I followed the included directions to assemble the printer. The process was straightforward, components and hardware are clearly labeled, and the instructions are easy to follow. The most challenging part was attaching the print head to the arms, as you need to stretch the very stiff springs. Once assembled, wiring the simple was also a breeze. However, I did notice the printer showed some signs of prior assembly and some minor cosmetic damage unrelated to shipping, which I easily fixed. With the printer fully assembled, let's dive into its specs and features. First and foremost, this is a Delta style 3D printer. A Delta Type 3D printer is unique due to its 3-arm configuration. Unlike traditional Cartesian printers, Delta printers use 3 vertical arms arranged in a triangular layout, allowing for rapid and precise movements of the print head. This design offers faster print speeds and the ability to handle taller prints with ease. One disadvantage is that Delta printers have to be quite tall relative to their XY build area. This printer is 33 inches tall, yet only has an XY build area of 260 millimeters in diameter, which is only a few millimeters more than my very compact Bambu Labs A1. However, the T1's height allows for a vertical build height of up to 330 millimeters, although in practice, I wasn't able to print that high. Delta robots have been around since the 1980s, originally used to sort and package small parts. In college, I was actually on a team that scratch-built a Delta Type plotter back in the early 2000s. The technology has been used in 3D printers for over a decade, and FLSUN has been exclusively building Delta Type printers since 2016. They've ramped up the speed of their printers, with the T1 hitting print speeds of 1,000 millimeters per second and 30,000 millimeters per second squared acceleration. However, again, based on FLSUN's own print profiles, actual print speeds topped out at 700 millimeters per second, with travel speeds hitting 1,000, which is still really fast. Other key specs include a maximum nozzle temperature of 300 degrees Celsius and a maximum bed temperature of 110 degrees. The print head features a dual gear direct drive extruder with a 0.4 millimeter brass nozzle capable of a flow rate of up to 90 cubic millimeters per second. However, doing some back of the napkin math, this printer as configured using FLSUN's profiles, 56 cubic millimeters was the fastest actual flow rate achieved. The T1 uses a 30,000 RPM CPAP turbofan for cooling located in the top compartment and connected by a vacuum tube, providing rapid cooling for high-speed printing. However, this turbofan is extremely loud. Other features include a textured PEI magnetic spring steel build plate, a 4.3-inch color touchscreen running the FLSUN OS, Wi-Fi capability, an included camera for real-time monitoring and time-lapse recording, a HEPA filter and exhaust fan in the top of the machine. The T1 is run by a Clipper-enabled mainboard and processor and includes vibration compensation, auto bed leveling, a filament runout sensor, and power loss resume. Okay, now let's look at some of these features in operation. Once I plugged in and powered up the printer, I was greeted by a quick setup, self-test, and calibration process. I chose my language, connected to Wi-Fi, and then the printer conducted some self-diagnostics, ran its vibration compensation, and auto bed leveling. The FLSUN operating system is fairly intuitive and user-friendly. However, the touchscreen sometimes lacked responsiveness, and there were issues with the OS, such as misspelled confirmation messages and problematic time-lapse video file names, with each new video overwriting the last. Additionally, sometimes the USB drive wasn't recognized unless I restarted the printer. These are minor issues which should be easily corrected with a firmware update. FLSUN sent over a spool of their high-speed PLA, so I loaded that up. The spool hangs right inside the machine at the top, making good use of the space between the control arms. On the internal storage, there was a Benchy model ready to go. I selected it, hit print, and the T1 started laying down filament fast. This is real speed. I'm not speeding the footage up at all. The T1 printed the Benchy in just 10 minutes. Fast, but there were some quality issues, warping in the bow, oval holes instead of round, separation in the top layers, sagging in the bridge above the window, and some minor stringing. Now, it's time to run a couple of my own test prints on the T1, so let's go over the slicing software FLSUN provides. While you can use virtually any Clipper supporting slicer, FLSUN ships the T1 with FLSUN Slicer, which is just a reskinned version of Prusa Slicer. The installation files are on the included USB flash drive, but I checked FLSUN's GitHub and found an updated version. Once installed, I added the T1 as my printer, and all the necessary machine parameters were already set, along with some basic print profiles. I'll get into filament considerations in a bit, but it's important to note that the included profiles are intended for FLSUN's high-speed filaments. First, to test the vibration compensation and ability to handle the print speeds, I dragged a ringing tower 3D printer test into the slicer, selected the FLSUN PLA profile for the filament I had loaded, and with the default settings, I sliced the model. Using the IP address assigned to the machine during setup, I added the machine to my slicer and was able to send the G code directly to the printer. One nice thing about a Clipper-enabled printer is that from within the slicer or by inputting the IP address into any browser on any device connected to my home network, including my phone, I can connect directly to the printer to monitor the machine stats, print progress, and even access the webcam for real-time monitoring. The T1 again laid down the filament fast, hitting print speeds of 700 millimeters per second and travel speeds of 1000 millimeters per second. It was pretty impressive, and so were the results. The ringing tower printed perfectly. Despite the speeds, there are zero signs of ringing or ghosting. The layers looked perfect with no signs of layer shifts. Super smooth surface. It's a perfect print. Using the same settings, I also printed an all-in-one printer test. And again, the print came out pretty close to perfect. No ghosting, no layer shifts. The overhang test is about the best I've ever printed, with no signs of problem until it hits the 75 and 80 degree points. The dimensional accuracy is within 0.1 millimeters on all axes, which is in line with the machine specs. The only problems I see are hard seams, so I'll change the seam setting from align to random, and the top surface text is pretty unreadable, which is common at 0.2 millimeter layer height and can also be helped by slowing down the top layer speeds. Now, with the FLSUN filament loaded and the print profile verified, it was time to print some stuff. First, I noticed the included camera doesn't actually fit the full build height of the printer in frame. FLSUN seems to have known this because they included a camera mount model on the internal storage, so I printed it out. Again, a great print, finished fast, and all the parts fit together and held the camera as designed. Next, I wanted to test support stability at these print speeds, so I sliced this dragon skull, scaled up to 200% with some organic supports. This is where I ran into my first issue. The print paused early in the job and gave me a dialogue warning that the filament was exhausted, even though it clearly was not. To make it worse, while I could load filament, even though the printer kept telling me there was none, I couldn't unload the filament. It just didn't work. I ended up cutting the filament and loading it until it was actually exhausted and tried to reload, but the printer just couldn't recognize there was actually filament loaded. I thought the filament sensor had failed, however, performing a total factory reset seemed to fix the problem. After resetting up the printer and resending the G-code, the printer knocked out this dragon head without issues. The support stayed in place, supported the model perfectly, and removed fairly easily without damaging the model. So, one problem encountered, but we're not done testing the T1. First, I wanted to test the full build area. To do that, I quickly used a spiral vase model, which I scaled up to nearly the full 260mm build diameter and up to the full 330mm height. Unfortunately, this didn't work. The nozzle exhibited inconsistent behavior, noticeably slowing down and lifting away from the print during one direction of travel, resulting in significant layer separation. I canceled that print and just tried a round vase. When not hitting the set perimeter speed, the vase did better. However, at the 93% point, or just 307mm, the printer just stopped, despite being 23mm from the max stated build height of the printer. I tested this again later with this large manifold printed in normal mode, and unfortunately it stopped at just 292mm. When I tried to move the Z height, the print head didn't move and returned a message that the print head had reached its max height. However, when I unlocked the print head, I was able to manually move the head up. Due to the Delta's design, the print head can only reach its maximum possible height in the exact center of the build area. In the center position, the T1 nozzle can just reach 330mm. However, moving the print head to the edge of the build area, one of the control arms stays at its max height, but the other two arms have to drop considerably, which brings the nozzle down to just 290mm. So the 330mm build height is just a straight up lie, and the machine knows this as it kills any print at around that 290 to 310mm mark. This completely eliminates one of the key features of a Delta type printer. Now, I was able to test 3 other filaments on the T1 before it died: the Sunlu High-Speed PETG, Creality Hyper PLA, and Bamboo Labs Galaxy PLA. I also had a roll of high-speed ABS and a spool of high-speed TPU that I wasn't able to test before the T1 gave out. A quick word on filament selection. This machine is designed for high-speed printing, so you need to ensure you select a filament designed for high-speed printing. Even then, you need to tune your settings appropriately, especially the speeds. If not, you'll run into problems. If you print too fast for the material, supports will fail, you'll get under or over extrusion, fallen bridges, surface zits and gaps. Going too slow, specifically with this printer, can be problematic too. For example, using the Creality Hyper PLA, I set the perimeter speed a little too slow for this dino skull and ended up with some very inconsistent flow rates, resulting in both surface gaps and zits. It's not bad, and I was easily able to correct it by increasing the perimeter speed for this dragon skull, which has a nice smooth surface. Unfortunately, this print failed at the end due to a firmware crash. For the Sunlu PETG, I used the included FLSUN PETG profile and just reduced the print speeds to match the 300mm per second max box of the Sunloop filament, I was able to print out this cool detergent cup holder and this controller and headphone wall mount, both printed fast and flawlessly using the FLSUN PLA profile and lowering all the speed settings to the 250 millimeter per second max of the Bamboo Labs Galaxy PLA. I was able to print out this mouse shell at the same 0.12 millimeter layer height. The quality almost matches the one I printed on my A1 with the same material. Unfortunately, these are the only successful prints I got out of the T1. These 9 prints failed. I've already talked about the tall vase and manifold. I actually printed 2 of the spiral vases. The second one with the Creality Hyper PLA, and the exact same thing happened. Right after the successful cap holder, I sliced an Xbox wall mount I designed in Fusion 360 using the same settings. I hung around to see the first layer laid down perfectly and then went out to dinner with my wife, only to return to, oh my God, a spaghetti explosion. I had no idea what happened, but whatever it was happened during just the second layer, so I printed the same file again and watched it closely. Halfway through the second layer, the print head just rose several centimeters and continued printing in the air. I repositioned the model, resliced, and tried again. This time it seemed to be going well until about the 25% point when there was a major x-axis layer shift. I scrubbed both versions of the G-code and found no problems. There were also no issues with the model as I printed it perfectly on my Tech Q1 Pro using the same settings and the same spool of PETG. My second attempt at the dragon skull just stopped at about 95% and the print progress actually read 0%. I think this was a firmware crash because the Moonraker interface I was monitoring also crashed. This dino jaw fail was partly my fault because I didn't add enough glue to the entire build plate surface area, causing the jaw to break free. Luckily, I was able to glue the model back down so the skull could finish and I didn't waste all that filament. I mention this because it highlights the lack of a skip or cancel object option that would be perfect for this very situation. Finally, after the successful mouse print, I wanted to test some more dimensional accuracy, so I sliced a spiral pass-through fidget. However, when I attempted to print it, the machine hard crashed. In fact, every print attempt resulted in a total system crash reboot. I tried a factory reset, but this time during the startup and self-test cycle, specifically at the start of the auto leveling, the machine crashed. I attempted to power down and restart a few times. In some cases, the heat up detector would fail, and in every case, the system crashed at the leveling phase. Eventually, on about the 4th attempt, the printer failed to reboot and just errored out with a flashing screen, or essentially a boot loop. That's it. Which is where we are now. This is a giant bricked 3D printer. Quick addition, guys, as I'm editing this video, I received a new message from FLSUN. I'm gonna send back the T1 so their techs can diagnose the problem and develop solutions. Once they do, at some future point, they'll send a fixed printer for an updated review. This is great, and I applaud their efforts to ensure a high standard of quality and reliability in their product. However, it doesn't change the fact that this printer had multiple problems before completely failing, yet it's gone on sale today despite no attempts to correct even the minor firmware issues or marketing accuracies. So while I look forward to reevaluating an improved T1, at this point in time, my conclusion, which you're about to see, hasn't changed. Bottom line, while I can only review what's in front of me, this printer had a greater than 50% failure rate before the machine itself completely failed. within just 2 weeks of assembling it. Combined with the fact that FLSUN just straight up lied about the capabilities of the machine, specifically the build volume and flow rates, I can wholeheartedly say, for the first time on this channel, do not buy this product. While it has potential and gave us glimpses of potential greatness, in its current state, it's just not up to the challenge of long-term reliable 3D printing. Hopefully, at some point in the future, FLSUN will work out all the problems with the printer and correct their marketing BS. But in the meantime, you won't find any affiliate links below. This printer is a bust. Don't buy it. And there's nothing more to say except, like, subscribe, comment, and I'll see you in the next one.